Talk about acids, bases and alkalis, and the reason I put alkalis in brackets here is because an alkali actually is just one example or one group of bases. So often you'll hear people say acids and alkalis. Acids and bases is the more general term. What an alkali is a soluble base. So some bases are not soluble, but they're still the opposite to acid. Alkalis are only the opposite to acid if they are soluble. So a base is only an alkali if it is soluble, okay? And so the relationship between an acid and a base, or an acid and an alkali, is that they can be involved in neutralization reactions. Neutralization reactions. So what this is actually defined as is when an acid plus a base, notice I've written base here and not alkali because sometimes it's not an alkali, react to form a salt plus water. So acid plus base makes salt plus water. Now, important to realise here is that even though it's known as a neutralisation reaction, we won't always end up at an exactly neutral pH. But you know that an acid has a pH below 7 and a base has pH above 7. When you join them together, normally you're taught that you will end up with a pH of 7. So pure water has a pH of 7. However, sometimes if you don't have the right amount of acid or base, your result is not going to be 7, but you will still have a neutralization reaction take place. Okay, so let's have a look at some examples of different acids. Now the most common one that you'll probably hear is hydrochloric acid, and that has a formula HCl. So we have one hydrogen and one chlorine forming our hydrochloric acid. Now what happens is that when hydrochloric acid dissolves, these two separate into ions, and so we have hydrogen plus and chloride minus, and so we have HCl forming H plus and Cl minus, and because these are in solution, we write this state symbol, aqueous. All that means is dissolved in water, so anytime you have a solution, you're going to see aqueous next to it. The only exception to that is pure water itself, because that is just liquid water. And so our HCl here could be in any state we like. It could be HCl gas. That would be hydrogen chloride gas rather than hydrochloric acid, because we call it hydrochloric acid once it is actually dissolved in water. Okay, now an important feature here is, or the most important feature here, is this, your H plus ion. This pretty much tells you that you have an acid. Almost all acids will form these ions, H plus. Okay, all the acids that you will look at in your GCSE course are going to form H plus. And so another example you may have heard of is sulfuric acid. Sulfuric acid. Now sulfuric acid is H2SO4, and that will go on to form sulfate ions, which are 2 minus. This is in solution, remember. And also, well, we have 2 of these hydrogens, so we're going to form 2 lots of H plus. The reason I haven't put the 2 here is because those 2 H pluses are separate of each other. We don't have 2 H pluses as a molecule, so there's only one of them. So it's going to look like this. Now this is known as dissociation, when we have acid dissociating into its ions. And so this H plus tells you that this is an acid. And now pause the video and try and see if you can write the dissociation of nitric acid. So I hope you had a go. Nitric acid only has one hydrogen and it has NO3, which is your nitrate ion. Now if you have only one hydrogen, which is a +1 charge, our nitrate ion is a -1 charge. and so we have NO3 minus and our H plus. If you notice, the charges will always balance each other. So we have a plus here and a minus here. We have a 2 minus on our sulfate because we have 2 lots of H plus. So plus 1 makes 2, and then we have to minus 2, so it's a 2 minus. One last one you might have seen is phosphoric acid, and that is H3PO4. So have a guess as to what the charge is going to be on our PO4 phosphate ion. Hopefully you can see that we're going to have 3 hydrogens, so 3H plus, and therefore PO4 is what charge? A 3 minus charge. Now, we have slightly simplified the dissociation of acid, going straight from our acid to the 3H plus. It does in real life actually occur one at a time, but this is just to give you an idea of what is happening with acids when they are in solution. And so we've spoke about acids in solution, so how about bases in solution? Well, one thing to remember is that a soluble base is known as an alkali. So if we're talking about a base in solution, we can just call that an alkali, because in solution means it has dissolved, and that means that it is an alkali. So one example, a common example, is sodium hydroxide, NaOH. Now important here is that the ions are sodium and not H plus this time, but a hydroxide ion, which is going to be a -1. And so we have our sodium hydroxide dissociate in solution into its ions, Na plus plus OH minus. And these are the ions which are going to be formed. The hydroxide ion, just like the hydrogen plus ion, is indicative of an acid. The hydroxide ion is indicative of an alkali. So forming this hydroxide ion suggests that our original substance is an alkali. Okay? And so we have actually formed our 2 ions, and remember, as they are in solution, we write aqueous, like so. And so what if we add something like calcium hydroxide? Well, calcium is not going to have a +1 charge, it's going to have a +2 charge. And so to balance that, we need a 2 next to our hydroxide. Remember, in brackets, because it's the entire hydroxide ion we're going to have 2 of. If this breaks apart, or dissociates, sorry, we're going to get our calcium ion, which is a 2 plus in solution, plus our hydroxide ion in solution, but because we have 2 of them here, we are going to have 2 here. Okay? Again, the reason why we won't say in brackets and then a 2 down the bottom is because this is not a hydroxide molecule. 2 hydroxides don't bind together, they are formed separately, and so we have 2 of them, meaning we have the 2 in front of the hydroxide ion, and obviously brackets around there. And so a final point is, how do we measure whether something is an acid or is an alkali? The way we do that is we have a scale known as the pH scale. pH scale. You don't need to know what pH stands for at the moment. If you are interested, this H actually just means hydrogen plus ion. And so, therefore, hydrogen plus being from an acid, we can measure whether something is an acid or whether it's not an acid, like that. The pH is going to have a value of between 0 and 14. We can, in very special cases, go above 14 and go below 0, but you are not going to see any of those examples in your test. So we have a scale of 0 and 14, and obviously slap bang in the middle of 0 and 14 is the number 7. The number 7. Now 7 is the neutral pH. Neutral pH. That means if something has a pH of 7, it is not acidic or alkaline, it is neutral. And so pure water is often referred to as being pH 7. It is pH 7 because it is not acidic or alkaline, it is exactly equal of both, and so it is neutral. And now if we add acid, so if we plus acid to water, which is at pH 7, we are going to move this way on the scale. So an acid has a pH of less than 7. So really between 0 and 7. So as you go further towards 0, your acid gets stronger and stronger. So this is strong acid. pH 0 is extremely strong acid. And so as you get closer and closer to pH 7, then you're getting weaker and weaker and weaker, and eventually at 7 you become neutral. As an example, rainwater is slightly acidic, so when it rains it's slightly acidic. We don't obviously dissolve, our skin doesn't fall off our skeleton because it's a very, very weak acid. So it's a pH of around about 6 or 6.5. Okay, and by the same token, do a different colour. By the same token, alkali, or base, more correctly, so base, alkali, will have a pH above 7. So it'll be 7 to 14. 14 is a strong base. So a strong base is probably just as bad for you as a strong acid. Often you hear about things being dissolved in acid and it's really awful. If you had a strong base such as sodium hydroxide, that is going to do some massive damage as well. That is why things like oven cleaners and bleach and things like that, they are made from heavily alkaline solutions because it helps just fight through things. It burns through things and it's just not a very nice substance really. Okay, so pH 14 will be very alkali or very basic, very strong base. As you get closer and closer to pH 7, you're getting less and less harmful. For example, seawater is around pH 7.5 to pH 8 because it's slightly alkaline, and so that is when it's not as harmful at all. Now the thing we use to actually measure this is known as an indicator, and the most important one that you need to know about is the universal indicator. So the universal indicator. Now this is special because it can measure pH across the whole range between 0 and 14. Sometimes it's just referred to as UI, so that means universal indicator. It measures between pH 0 and 14 and it will become a different colour at each different pH. And so when you are at pH around about 0, you have a very deep red, so like this. And then you go lighter and lighter and lighter, you get to orange and to yellow, so you get orange to yellow, until you get to neutral, at neutral pH, so pH 7, the universal indicator will turn green. And then you get darker and darker and darker, so blue, so darker blue, darker blue, darker blue, and then it turns purple, and a very strong base will come up deep purple. So I know that's not the best image in the world, so let's have a look here. Here we go. If you start off on the left hand side, this is around pH 0, so around pH 0 here, and then you're going up and up and up and up and up and up. Around here you're looking at pHs 6, 7 and 8, and then you keep going, now you're getting more blue, and eventually very purple on the right hand side, and that's going to be a pH of around 14. So you've got around 7 there, 0 here, and you're going up and up and up as you go through red, lighter red, orange, yellow, green, blue, purple, and then very dark purple on the right hand side. Okay, so I hope that's helped clear up exactly what an acid is, what a base is, and what an alkali is.